Hey everyone, let's do some 8.3. The feature in this section is paired data sets. Usually it's a before and after study, so these would be called dependent samples. The key players are these variables here that you'll find in the formula. N is the number of people in the study or number of pairs of data. Okay. D bar is the mean of the differences, and then mu sub d is the hypothesized mean of the differences. Now, since these are before and after studies, we'll be subtracting the before value and the after value. For the purpose of this homework, always do before minus after. So we're always going to be going before minus after. That'll be relevant when we get to these problems, okay? Otherwise, you've got your formula here. Although in this section, we'll pretty much rely on StatCrunch because you're always gonna have raw data on these. And so StatCrunch is way easier because you don't have to go and finding that S sub D standard deviation by hand, okay? And then if it asks for degrees of freedom, it's always the n minus 1, where n is the number of paired data values, or usually just the number of people in the study, okay? I'll get to this note here in a minute. It's just about finding that S sub D in a clever way. We might do that, or you might just rely on StatCrunch. But let's get to the example. So here's what these problems look like. They stand out because there's always this before and after type study. And then you have, in this case, 10 students, and there's a value before their preparation course and then a value after their preparation course. So as we can see, it looks like from student to student, the values tend to go up after that preparation course. So is there enough evidence to support the claim that this preparation course improves test scores? Okay, so how do these look when we set it up? You know, we're still doing those same 6 steps. So we're always starting with an H sub 0 or an H sub A. And these have to do with this mu sub D, where remember above, mu sub D is the hypothesized mean of the differences between the before and after. And we're always subtracting before minus after. So here, the claim is that the course will improve scores. So if we look at this, if we subtract 300 minus 400, we get a negative value, right? 300 minus 400 would be a negative 100. Here, a negative value shows improvement, though, because of the way we're subtracting before minus after. So actually, the claim here is that the mean of the differences is less than 0. Feels opposite because the word improve, you think greater than 0, but because of the order in which we're subtracting before minus after, it's actually opposite. So a lot of these, or all of these, will feel that way. Your inequality will be opposite of the wording, okay? And then H sub 0 is the opposite of that, okay? So this will be a left-tailed test, okay? If you're wondering about the verification step, usually step 2, we can go back way to the beginning of this where there's that summary. And then there's the 8.3 verification. Random dependent, either the population is normally distributed or n is greater than or equal to 30. So a lot of these are just going to say population is normally distributed. If it doesn't, we're just going to assume it. Okay, that's what we're looking for. There's also a summary right there. You're always going to use t distributions on these. And then there's that formula again. Okay. And then finding critical values and p-values is the same as what we've done before. Okay, so verification, we're good. Sorry about all the scrolling. It doesn't say that the population is normally distributed. It should, so we can run it. But that's an attention to detail thing. Okay, let's find that standardized test statistic next, the t-value. So when you're getting into finding the numbers, we're using StatCrunch for that, okay? So let me pull up my StatCrunch. I can share my screen for that. These values I've already preloaded, the before and after values. If you're doing homework, you should be able to load them into StatCrunch. This data set's also available to you under your groups folder. Okay, but we have that data set there, and here's how this StatCrunch feature works. So you're gonna go to Stat, and then go down to T-Stat, because we're using T-distributions in this section, and it's paired. Right, that's the new thing. Paired data values. That's your before and after, okay? So just stat, T-stats, paired. Column 1, we're always gonna do the before, and column 2 is the after, okay? Because StatCrunch will always go column 1 minus column 2. So just make sure before is in column 1, after is in column 2. And then I would definitely click this, save the differences. What that will do is create a third column with the raw differences of each student, okay? And then here, make sure this is always 0. And then this is just going to match your HA. So we had a less than. All right. It's really easy to get that one mixed up because of the wording and how it's always opposite. Right. So just make sure of that one. If you get a super large p-value, you probably just got that one in the wrong direction. And then that's it. Let's compute it and see what we get. Okay. So there's the results. So yeah, that makes sense. A p-value is super small. If you got a p-value of like 0.999, that probably just means your inequality is in the wrong direction. Okay. So what we got there is what we're after is that t statistic, right? The t is negative 6.80. We can also jot down that p-value, which is less than 0.001. It's so small that they couldn't even take it out to 4 decimal places, so it's just close to 0. And then we also have these differences here, right? That popped up. That's just subtraction, right? 300 minus 400, negative 100. Okay, so we can look at those, and all of those negative values is showing improvement, right? Because the after is bigger than the before. Okay. Now we can complete our problem by doing the rest of the steps, making our decisions, and that sort of thing. Okay. Oh, a few things. You know, that when you're doing the homework, you might be asked for this, that negative 60. That's the D bar, right? So when, if it asks you in your homework for a D bar, it's the mean of the differences, right? That's just finding the mean of all of these values right here. Okay. Another thing it'll ask you for is the S sub D, which is the standard deviation of these differences, and it doesn't give you this here. It doesn't give you that there. What I would do to find that, I would just use StatCrunch for it. Instead of, I gave a little formula in there, I would probably just do this, stat, summary stats of a column, back when we did this in chapter 2. And then just highlight the differences, and we just want the standard deviation. That's the standard deviation of the differences, and compute it. 27.9 approximately, right? That's your S sub D, okay? Okay, that's about everything it's gonna ask you for as far as your homework goes. So let's go back to the handout. And I wrote down those values. And now it depends. Are we using the p-value method or the critical value method? It'll bounce back and forth. Obviously, with the p-value method, I mean, your p-value is super small. It's definitely less than the alpha of 1%. So that always leads to reject H sub 0. Right? Just for a small p-value, it's always reject H sub 0. Okay. And if H sub A is the claim and you're rejecting H sub 0, the conclusion would be there is sufficient evidence to support. the claim. So it does seem like this prep course is helping. Okay. What if it asks you for critical values? I mean, we're done with this problem, but might ask you for some critical values, right? These are t-distributions. So you could go to your table for those, right? df is 10 minus 1, 9, left-tailed test, alpha 0.01. So I would go to my table and I would look that up. So for a left tail or a one tail test, there's one tail, 0.01, go down to df9, 2.821. That will be your t sub 0. Now, since it's a left tail, you got to put a negative on it. And that's how that works. So same way of finding critical values from 7.3, 8.2, all of those other t-distribution critical value, it's exactly the same. Okay, so that pretty much completes that problem. Notice how that critical value works, right? Left-tailed test, I drew it out. It's negative 2.821. Your t statistic here is well inside that shaded region. Negative 6.8 is way in there, right? So it's in the shaded region, still leads you to reject H sub 0. Okay, let's try one more. If you wanted to give that one a try first, go ahead, pause the video, give it a go, and then I'll work it out here. So pause now, and then you'll see it up here in a minute. Okay, here's the StatCrunch version. I go stat, tstat paired, once I got that data in there. And this one's in your groups folder if you want to try this one. I always click the differences because that's going to help me get that SD. And then this one is going to be a greater than, right? Did you get that? So it's a right tail test on this one. And that gives me the values I really want. I want that D bar, T, P value. If I want to get that S sub D, because I got this new column now of the differences, I go summary stats of a column, choose differences and standard deviation, and compute that, okay? And I get my standard deviation of 0.62, okay? So let's finish this one off. Going back to the handout, and this is how it looks. So notice this one says reduce the length of time. So if before and after reduces, if you subtract them, that's bigger than 0, right? If you just kind of look at all these, subtracting them, you get a value that's positive. Okay, so again, it has that opposite feel. Reduce lengths, it's greater than 0. All right, and those are all the values I just found with StatCrunch. I found this using the t-table. It's a right-tailed test, so it's a positive 1.812. I use DF10 and 5%. Okay, and then I notice that the t-value is in that shaded region. If it's in the shaded region, it's reject H sub 0. Oops, why did I erase that? I meant to highlight it. Reject H sub 0. So there's sufficient evidence to support, right? Because HA was the claim, and we rejected H sub 0. Okay, so that's that kind. Give it a go. Try to practice those and see how they go, and let me know if you have any questions. All right, hope all's well. Talk to you later.